Okay, so we're going to look at some questions on similarity. Now we know these are similar triangles because it states it, and it's asking us to find scale factor and the value of x. So make sure we read that question. So let's look at our triangles. There's x, and we want to find a scale factor. So two common sides that we know are 5 and 8. So we're going to use these to help find our scale factor. So 5 must be multiplied by something, and we're going to call that scale factor, to equal 8. All right, and what we do, as we've shown, we do the reverse operation of timesing by 5. We're going to do divide by 5. So we're going to go 8, and instead of timesing by 5, we're going to bring it over here. We're going to divide by 5. So again, if we're using our calculator for this, we have a nice simple 8 divided by 5 gives us 1.6. So our scale factor is going to equal 1.6. Now we're going to use that to help us find x, hopefully. Okay, so the corresponding side to x. So there it is, 5 times 1.6 gives us 8. Now 11 has therefore got to be multiplied by the same scale factor to get x. So we're simply going to go 11 multiplied by 1.6. And again, if it's calculator allowed, we can just take our calculator, multiply it, and we get 17.6. Okay, let's look at B. So again, we want to find the scale factor, and then we want to find the value of x. So first thing is to find the corresponding sides. So our corresponding sides are there, 2.75 and 1.1. All right, now one way of looking at this is we can take 1.1, we're going to multiply it by some scale factor to get to 2.75. All right, so now what we want to do is divide the other side by 1.1 to do the opposite. So 2.75 divided by 1.1 is 2.5. And that's our scale factor. So let's think about this. We're going to go 1.1, we're going to go times by 2.5, it's going to give us 2.75. If we go backwards, we do the reverse. So we're actually going to go 5 divide by 2.5 to find x. Okay, so to find x, remember, we're going to go 5 and we're going to divide it by 2.5 because we're going to the smaller triangle, and that's going to equal 2. Now let's check it. Yep, it equals 2. Good. Okay, so let's look at a second question. We want to find the scale factor of the pair of similar triangles. We know they're similar, and we want to find the scale factor. So let's find corresponding sides. We've got 4 and 10 correspond. So 4 times something must equal 10. Again, if we're using our calculator, it makes this nice and simple. We're simply going to divide by 4, and that's going to give us our scale factor of 2.5. And that's it. Check the question. We're done. Okay, so let's look at another question. We've been asked in this question to give a reason why the two triangles are similar. So we've got to determine if it's side, 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 angle, 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 or right hypotenuse side. Okay, so I've got a smaller pink triangle and a yellow triangle that's slightly larger. So one's been enlarged or one's been reduced. I can see that x and 13 are opposites, so they're corresponding. I can see that 60 degrees is this 60 degrees because of vertically opposite angles are equal, so I can write that in. Now, what I also noticed that I have parallel lines. Now, that means this angle here must equal that angle because they're alternate on parallel lines and they're equal. And that also means this red little angle down here equals this red little angle down here. So all 3 angles in the little one equal all 3 angles in the big one, and that means I know my test is going to be angle, angle, angle because they're all equal. Now, what I want to do is I want to find the value of x. So I've got to find corresponding sides first to determine if it's enlarging or smalling by a specific value. So timesing or dividing by a value. So I'm going to draw the 2 triangles out to help me here. I got 60 degrees and 60 degrees there from knowing. I got a 6, and then I got x, and then I've got a 12, and then I've got a 13. All right, so I've got to find corresponding sides that have numbers on it. It's probably easy if I put my angles in there as well from my parallel lines. So I know that x and 13 are opposite because they're opposite 60. There's my blue angle, there's my blue angle. Now I can see that 6 is between the blue and the 60, and 12 is between the blue and the 60, and so they're corresponding. So 6 and 12. So 6 was multiplied by 2 to get 12. To do the reverse, I divide by 2. So that means I'm going to do 13 divided by 2 to determine the value of x. And that means x is going to equal 7.5. Alright, let's look at a second example here. So remember, we've got to determine whether they're similar and determine what test it is. So let's first of all break it into the two triangles. So we've got combined triangles here. We've got a small pink one and we've got a big large blue one there. And then we can put down information that we know. So we know that this angle is shared by both the triangles, so we know that angle is the same. We know we've got a right angle in both the triangles, and that means that this third angle must be the same because the angles in a triangle all add up to 180 degrees. So our test is AAA. Now, let's put our details of 4 and 5 onto our smaller triangle, and then let's look at what we've got for our bigger triangle. So we've got 4 and 4, so that's going to give us 8. So that long side is 8, okay? We've also got x on this side, so we know that x has got to be found, so we've got to look at the scale factor. 4 multiplied by some scale factor equals 8. We can see the scale factor is going to be 2, same as dividing by 4 there to give us 2. And so 5 times 2 gives us our value for x, and x is equal to 10.